Okay, the next one of these limiting reactant problems, right? It says the reaction between solid sodium and iron 3 oxide is one in a series of reactions that inflates an automobile airbag. And the question is asking what mass of solid iron is produced. And I'm given an amount of both reactants, 100 grams of iron 3 oxide, that's Fe2O3, and 50 grams of sodium. So I'm going to go through those steps, right? Step 1, convert both to moles. Step 2, convert reactant 1 to reactant 2. And then step 3, compare them to see which one, well, basically seeing, do I have enough reactant 2? So in this case, do I have enough sodium to use up all of my iron 3 oxide? So step number 1, we said, was convert both of those to moles. So 100.0 grams of Fe2O3. We should be pretty good at doing, gram to mole calculations by now because we've been doing them for a while. And this is 0.626 moles of Fe2O3 that I have, right? This is how much I have at the beginning. And then 50.0 grams of sodium. Again, I convert that to moles. 1 mole of sodium is 22.99 grams. And so I have 2.174 moles of sodium, right? And I can't just go with, well, which one is lower? Because if I look at the balanced chemical equation, you can see that I'm not using these 1 mole to 1 mole. I'm not using 1 mole of sodium and 1 mole of iron 3 oxide. I'm using 6 moles of sodium. So I can't just say, hey, I have less iron 3 oxide, so that must be the limiting reactant. Remember, this is reactant 1, and this is reactant 2, and this is reactant 2 that I have. The second step here is going to be converting reactant 1 to reactant 2 using the balanced chemical equation. So basically answering the question, if I were to use 0.626 moles of Fe2O3, how many moles of sodium would I need? And this tells me that I will need 6 moles of sodium for every 1 mole of Fe2O3 that I have. And so therefore I will need to use 3.757 moles of sodium needed. So really think about what all these numbers mean, because a lot of times students get confused with looking at these 3 numbers and sort of figuring out what they mean. This is saying, basically the question that you're asking yourself is, can I use all of this? And what we just figured out here was, well, to do that, I'm going to need to use 3.7 moles of sodium. I have 2.1 moles of sodium. So since I need more than I have, right? I need more than I have. That means that it's not going to be in excess. That's the one that's going to get used up. I need to use 3.7 moles. I only have 2.1 moles. So sodium is the limiting reactant. Right? Write a sentence stating your limiting reactant and the reason you used to come to this. So, we need to answer the question first. The third step, right, is figuring out the kind of logic to it. And then finally, we're actually going to do the actual, answer the question. The question said, what mass of solid iron? So now that I know that sodium is the limiting reactant, right, now that I know that sodium is the limiting reactant, I'm going to start with the amount of sodium that I have. I'm not going to start with this. I'm going to start with the amount that I have, which is that 2.174 moles of sodium, right? According to the balanced chemical equation, 2 moles of iron will be produced from 6 moles of sodium, and 1 mole of iron has a mass of 55.85 grams. And when I put that into my calculator, I get 40.4886 grams of iron. And this is where I start to think about significant figures, right? I go back to the data in this problem. So what was this? I used the sodium. That only has 3 significant figures. My iron oxide has 4. But since that is my limiting reactant, since sodium is my limiting reactant, this number only has 3 significant figures. My answer can only have 3 significant figures. So 40.5 grams of iron is the maximum amount of iron that can be made. Right? So now we write a sentence about that limiting reactant. Right? So the first thing I do is remember, you can kind of think of this as claim, evidence, reasoning. My claim is, what's the limiting reactant? So the first thing that I'm going to say is 50.0 grams of sodium is the limiting reactant. Right? And then I'm going to say why. And remember, what I'm asking is, can I use up all reactant 1? So this is in order to use all the Fe2O3, right? The 3.757 moles of sodium would need to be used, right? I only have 2.174 moles of sodium, right? Sodium will run out first and is the limiting reactant. Right? Because we're really using logic, that's why these sentences are so important, so that we can see your thinking here. And then, of course, right, we always have this problem, what mass of the excess reactant is left over? So the first thing we just said, sodium was the limiting reactant. So what is my excess reactant? That's that Fe2O3. And how do I find how much is left over? Right? We use this acronym SUE. And it's always going to be, well, how much did I start with, right? And I go back to the original question. I started with 100.0 grams of Fe2O3. I have to figure out how much I used, and I subtract that, and that will tell me how much excess I have. So I have to figure out, well, how much I used. When we do these, we always go back to the limiting reactant because that's when the reaction stops. So when I use 2.174 moles of sodium, how much iron 3 oxide will I also use? The balanced chemical equation says I will use 1 mole of iron 3 oxide for every 6 moles of sodium. And that for every 1 mole of iron 3 oxide, it has a mass of 159.70 grams. So how much Fe2O3 will I use? I will use 57.887 grams. Okay, before I start kind of moving on to actually doing the subtraction, I need to remember that subtraction deals with decimal places, but the multiplication I did here and division deals with significant figures. Remember what I started with, right? 50.0 grams of Na. So if this number only had 3 significant figures, my answer would only have 3 significant figures, 57.9. How many decimal places would that number have? Well, it would have 1 decimal place. So when I go to think about this problem, this number has 1 decimal place. I'm subtracting from it a number with 1 decimal place. So my answer will have 1 decimal place. Okay, But now I use the unrounded answer. Remember, we don't round to the very, very end. So 57.887 grams. When I do that subtraction, I'm going to get 42.112, and then I round it to 1 decimal place, 42.1 grams of Fe2O3 left over. And if you are doing this and you get like a negative number, so if this number right here came out to be greater than 100, that is, you can't have a negative amount left over. That would be a really big clue that you've done something wrong. So you would go back and sort of trace your steps. Did you choose the right limiting reactant, right? Are your molar masses correct? Those would be the things that you would try and figure out if you get these problems, if you get to this point and it's not a positive number here. So let's just review what we did. Step number 1, we converted both grams to moles. Then I asked the question, how many moles of reactant 2 are needed to use up all of reactant 1? And I got 3.57 moles of sodium is needed to use up all my Fe2O3. But since I only had 2.17 moles of sodium, that's going to run out first. So then I start with my 2.17 moles of sodium and figured out that I could make 40.5 grams of iron. And then how much of the excess reactant is left over, right? I took my limiting reactant and I found out how much of the other reactant I would need, and then subtracted how much of that other reactant, the excess reactant I had, and I subtracted how much I used. And then I finally get how much is left over. So if you feel confident in doing these problems, maybe try the next one on your own and then check your answers, or you can watch the next video, which will just go through this problem step by step.